In this video, we're going to focus on how to write precipitation reactions and how to simplify them to net ionic equations. Our first question says, write a balanced equation for the reaction between sodium acetate and hydrochloric acid. So my first step is to remember the formula for these particular chemicals. Sodium acetate is an ionic compound made out of sodium and acetate, which has the formula C2H3O2 with an overall negative charge. Hydrochloric acid is written as HCl. So first of all, I need to make sure that my ionic compound is balanced. Since both of these are positive 1 and negative 1, we only need one of each in our equation. Then I'll add the acid. And then I will do the normal pattern of switching the cations to find my products. I'll end up with sodium chloride and acetic acid. The next part of this is to figure out if I have any spectator ions. So first, I'll check my solubility chart. Sodium acetate is soluble, the strong acid, hydrochloric acid, is soluble, and so is sodium chloride. Since sodium chloride is all aqueous, and both the sodium and the chlorine are also aqueous on the reactant side of the equation, I know that both sodium ions and chloride ions will not be in my final net ionic equation. I will, however, need to include my acetate. Since acetic acid is a weak acid, it usually exists as a molecule in solution. My net ionic equation then, without my spectator ions, will be acetate ion plus the hydrogen ion yields acetic acid. In this second example, we have different chemicals. We have silver nitrate and ammonium carbonate. The first thing I will do again is write out my ions so that I can make sure I write balanced formulas. The silver always carries a 1 positive charge, and the nitrate a negative 1. Ammonium ion, positive 1. Carbonate, negative 2. So when I write my first round of the reaction, I'll have silver nitrate adding with ammonium carbonate. This next part is where we switch where the cations are to form the products. We'll need to have 2 of those silver ions to match that negative 2 on the carbonate, and only 1 ammonium ion to balance the negative on the nitrate. Now we need to check to see if each individual piece is going to be soluble or insoluble. Silver nitrate is soluble because of the nitrate always being soluble. Ammonium carbonate is soluble since the ammonium is always soluble. But silver carbonate, this guy will be a solid. Ammonium nitrate, because both ammonium and nitrate are always soluble, is going to be aqueous, which means that my ammonium is my spectator ion, and so is my nitrate. This leaves us with the silver ion adding with the carbonate ion to yield silver carbonate. We will need to remember to balance that silver so that the charges will cancel out and become neutral. And that's how you write precipitation reactions and then summarize them down into net ionic equations.